All right, so today we're going to review our multiplication rules and our division rules of exponents. If you look at the vocabulary, we already went over this. A monomial example is just a number, a variable, or a product of a number and a variable. Okay, you've got your base and your exponent, and we call it a power. Everybody good? All right, what is the multiplication rule? If you're multiplying and the bases are the same, what do? You add. So I'm going to look at these examples. These are super easy. I'm going to highlight the bases that are the same because that's my strategy that helps me. This is going to be 5 to the 2 plus 6, which is 5 to the 8th. Okay, y'all try this one on your own. You should have done y to the 4 plus 3 plus 1, which is y to the 8th. Now, when we've been grading y'all's papers and I've been looking at them, one thing I'm noticing is that, first of all, you're forgetting to deal with regular numbers with regular numbers. This means 7 times 6. So you do have to deal with those. And 7 times 6 is 42. Now I can deal with my exponents that have the same base, and I can put those together by doing y to the 5 plus 1, which is y to the 6. Okay, I want y'all to try this one on your own. Are we already done? All right, the first thing you should have done is multiplied negative 3 times 5, which is? Now, do I care if a number is negative? No. What is the only thing I care about? I can't have a negative exponent. So don't get confused. If a number is negative, that is perfectly fine. It's just a negative number. All right, let's go deal with our exponents. I've got x squared and x, so that's going to be x to the 2 plus 1. And then I have my y's, which is going to be y to the 7 plus 6. So I've got x to the 3rd, y to the 13th. Are we good on multiplication ones? Again, it's when the bases are being multiplied and there's exponents involved. If the bases are the same, add the exponents. All right, let's look at division. When you're dividing, if the bases are the same, then you subtract the exponents. So here I have bases that are the same. I always pull the subtraction problem to the top of the fraction to deal with it. So like this is y to the 1. But it's going to come out, and I'm going to say y to the 6 minus 1, and it's on top of the fraction while I deal with it. Okay, 6 minus 1 is 5. Since 5 is a positive exponent, it stays on top, and there's no more bottom number. Does that make sense? All right, over here I have the same bases. So I have 6 to the 13 minus 2. 13 minus 2 is positive 11, so that stays on top. Any questions so far? The last one, you've got regular numbers to deal with. Deal with them first. This is a division problem that can simply be simplified. Now, a lot of you are struggling simplifying. Just use your calculator. All you've got to do is go to alpha y equals and put in 10 over 15, and it will simplify that fraction for you if it can be simplified. Okay, for those of us who don't need our calculator, we're simply dividing the top and bottom both by 5. Very good. So the top is going to become 2, the bottom is going to become 3. Now I'm going to deal with the a's because their bases are the same. I'm going to pull them to the top to subtract them. So I have a to the 7 minus 5. Now I'm going to deal with my b's. I have b to the 9 minus 9. Are we good? All right. 7 minus 5 is positive 2, so it's going to stay on top. 9 minus 9 is 0. And any time you have a power of 0, it cancels out and becomes 1. That's the rule. So 1 times anything is the other number, so it's just kind of gone. Make sense? All right, so I have 2a squared over 3. And the b became 1 because b to the 0 is 1, so we don't write it. Go to the back. Power of powers. If you have parentheses, then you multiply the exponents. And the power gets distributed to everything in parentheses. All right, so this one becomes x to the 2 times 8, which is x to the 16. This one becomes y to the negative 3 times negative 4. And what are two negatives? So y to the, it's a good answer because it's a positive exponent. Good? Moving on, power of products. Again, if you have parentheses, then the exponent outside the parentheses gets distributed to everything inside of the parentheses. Everybody good? Here we go. This 3 is going to get distributed to the 4, to the x to the 3rd. So what's 3 times 3? 9. Y to the 3rd, z to the 3rd. Can anything else be combined? No, but can I expand 4 to the 3rd? Yes, 4 to the 3rd is 64. So 64, x to the 9th, y to the 3rd, z to the 3rd. Okay, my exponent of negative 2 is going to be given to everything in parentheses. So I have 7 to the negative 2, x to the negative 2, y to the negative 2. Excuse me. Nobody said anything. Y to the what? Because negative 2 times negative 2 is 4. All right, let's deal with our negative exponents. What do we do with negative exponents? Move them to the bottom. So what's the only thing that's a positive exponent? Y to the 4th is going to go on top. 7 squared. Now, when you move them to the bottom, you get rid of the negative sign. This becomes 7 squared, x squared. Do not put the negative sign once you move it to the bottom. Make sense? All right, can I expand 7 squared? So I have y to the 4th over 49x squared. All right, see if y'all can try the last one on your own. Check step 1 and see if you got it right.
Is it fine if we don't even put the z?
Yes, I'm just showing my work right now. But this is not a good answer, is it? what's going to have to go to the bottom? 6 squared. And what is 6 squared? No. Okay, so stop. Let's show our work. X to the 12th, y to the 14th will be up top. When I move this to the bottom, what goes? The negative sign. So it's just a 6 squared. Make sense? Now it's x to the 12th, y to the 14th over 36. There is no more negative sign because I moved it to the bottom. All right, let's talk about power of a quotient. Power of a quotient is the same thing. If there is an exponent on the outside of parentheses, it must be distributed to everything in the parentheses, yes? All right, here we go. The first one. This is going to be 3 to the power of 2 over 5 to the power of 2. This one, what is this going to be? 2 to the power of 2. A to the 5th is raised to the power of 2, so a to the 10th over b to the 14. Can anything be combined? I can't combine anything, but can I expand 2 squared? So 4a to the 10th over b to the 14th. Okay, y'all try this one on your own. All right, so I have 3 raised to the power of 3, a to the 4th raised to the power of 3, and b to the 7th raised to the power of 3. Yes? The only thing I can do is expand 3 to the 3rd, which is 27. Last one. A to the 12th, b to the 30th over c to the 66. Nothing else I can do. All right, let me pass out your... Let's do number 1 together. I'm going to take my highlighter and highlight the different colors. So I've got a regular number all by itself on the bottom. So where is it going to stay? I mean, it's not all by itself. I have a regular number on the bottom. It's going to stay on the bottom. All right. I've got S's that need to go with S's. And I got D's that need to go with D's. Everybody ready? So if I want to show my work, 5 is going to stay on the bottom. To subtract the S's, I pull them to the top. So I say S to the 1 minus what? Negative 5. Yes, it is 1 minus negative 5. Because your 1 is here, your subtraction comes with the rule, the negative 5 is there. Good? Okay, D to the 1 minus negative 2. Use your calculator if you need to. What is 1 minus negative 5? So since it's positive, it stays on top. S to the 6. What is 1 minus negative 2? 3. It's positive, it stays on top. 5's on bottom. There's your answer. Are we okay? Let me see if there was anything else that was kind of confusing. Let's do number 10, and then you're going to be on your own. Nine sevenths. Can that be simplified? No. So 9's going to stay on top, 7's going to stay on bottom. So I have 9 on top, 7 on bottom. I'm going to deal with the C's. C to the negative 5 minus 5. D is all by itself on the bottom, so I'm just going to keep it there for now. D to the negative 4. Everybody okay? All right. I have 9C. What is negative 5 minus 5? Negative 10. Over 7D to the negative 4. Can I have negative exponents in my answer? If the negative exponent is on top, pull it to the, if it's on bottom, pull it to the, it's that simple. So this is going to be 9D to the 4th on top, 7C to the 10th on bottom. They switch spots because you can't have negative exponents. Make sense? All right, get busy.